So I want to remind you, don't write this down, okay? I just need you to follow along and pay attention. So back when if we did this year, you did it hopefully in Algebra 2, but either way, let me remind you about inverse functions. So here I graphed for you a parabola, just the basic parent function y equals x to the second power. I made a table of values. There's what it looks like. It's a function. It passes the vertical line test, okay? Fine, wonderful. Then if I said to you, find the inverse of this function. Inverse, remember, is switching the x and y's and solving for y. And so that's what I did here. I took this function, I switched the x and y's, I solved for y, and in that process I took the square root of both sides. And remember, when you take the square root of something, you get a plus and a minus in front. Here's what that graph would look like, okay? And it's these ordered pairs, which are just these x and y's flipped. Okay, and you can see there's repeat x values here, which means it's not a function. It doesn't pass the vertical line test. So let me back up. Before you even do all of this, you could look at this and tell that its inverse is not a function because it doesn't pass the horizontal line test. Okay, because that just means if I flipped it, it wouldn't pass the vertical line test. Okay, so how do we go from a function to not a function? Well, that shouldn't happen. What we have to do is restrict the domain, or the x values. So when we're finding the inverse of a parabola, for example, and there's other functions in the function world that when we do the inverse of it, it's not a function. So what we do is restrict the domain, meaning we say, all right, we're not going to graph all these x values. We're going to restrict it to like 0 to infinity or negative infinity to 0, meaning you would only get half of the graph. So if I use y equals positive square root of x, it would just be this. If I use negative, it'd just be this. One or the other, that's restricting the domain, not using both the plus and the minus. Then it passes the vertical line test. So when you restrict the domain of a function to make the inverse a function, that's what we're talking about. And that's what happens with all of our trig functions. You know, I'm calling them trig functions. Wait, that's not the first page. All right. So what we're going to be looking at is inverse trig functions. So if you're a function, your inverse should be a function. If it's not, we restrict the domain of the original function to make its inverse a function. Lots of function words in there. First thing, before I show you how to do it, is knowing the symbols. That's the notation. Okay, I went over this at the beginning of class in first period and second period, and I still, when they got the homework and it said arc sign, I had at least 3, 4, 5 people in every class ask about it. So just remember, this is the most common one. This is the one I use. I use like sine to the -1. Just like here, I use, you can't really see it, y to the power of -1. That's inverse, okay? And this goes for cosine and tan as well. So you can have arctan or arc cosine. So that's used more in calculus. You'll start seeing that. We can use either one in this class. And really in calculus too. It just depends, okay? So let's just look. And by the way, there's no graphing in this. These graphs I'm going to explain to you, I hope explain how we restrict the domain to get our answers to the type of questions you're going to be asked. So here's a sine function, right? Middle up, middle down. And it continues on and on forever. We know this. And it's a function. It passes the vertical line test. But it fails the horizontal line test, okay? Meaning if I switched all those x's and y's and graphed them, it would look like this would be my x-axis, this would be my y-axis, and it wouldn't pass the vertical line test. Now, I don't need to graph it to know that. I can, again, one more time, use the horizontal line test to see that the inverse is not a function. So what we do is we restrict it. And, you know, just like with a lot of the math that we do, somebody makes a decision of what we're going to use. What part of sine are we going to use that makes sense? And this to this, which is negative pi over 2 to pi over 2, is a good section of sine. Here it is with everything chopped off. So this is this by itself. And then this, kind of confusing, so listen, is just this with the x and y's actually split. So this does pass the vertical and the horizontal line test, and you can see this passes the vertical line test. So look at your x values on this graph, the original function, negative pi over 2 to pi over 2, and y values from negative 1 to 1. Now they're flipped. X-axis is negative 1 to 1. Y-axis is negative pi over 2 to pi over 2. So your x's and y's flipped. The graphs look kind of similar, but the concavity is different, if you notice. You don't have to graph this. I just want you to know this part, and that's what we're going to go to on the next page. So what we're going to do with this is we're going to talk about the values of sine at these angles. Okay, so right now I'm going to walk away from inverse sine for a second, and I want us just to remember the unit circle, because here's the thing. We haven't used the unit circle a whole bunch in the last week-ish. We were graphing on the unit circle, but you didn't have to remember like pi over 3, sine of pi over 3, or whatever. We're back to it. I wasn't kidding when I said you have to know the unit circle. And all next week, we're going to be solving trig equations. You have to know the unit circle. You cannot get through it without it. So I will be reviewing in this lesson all the little tricks that you need to know. So this is a really, really good one for you guys to tune into, or go back and watch if you need a refresher about how we come up with these. And I want to remind you, I don't mean flashcard know it, where I don't have flashcards, where you are like sine of pi over 4, square root of 2 over 2. You know what I mean? That's not what I mean by knowing it. As I go through this, I want you to see how my brain works. And if you have another way, great. But whatever, you have to know it. So let's talk about all the sine values. This is just regular, and then we'll talk about what we're doing. So I want the sine values of all these. Let's just start at 0 and go positive. So anytime I'm at a quadrantal, I don't mess around. And I don't want you guys to either. Remember, this is 0 pi. Same thing. I need the ordered pair. So in my brain, I have to look at it. Sometimes I draw it in the air, that I'm going to the right 1, up or down 0. Right? That's the ordered pair there. We get it messed up all the time. And I need to remember that cosine comes first, sine comes second, right? This is x, this is y. So sine at 0 is 0, okay? Now, this one we know, right? I don't think anyone ever forgets the denominators of 4. It's these two that we confuse. So think about the unit circle. I don't know the answer like this, me, and I promise you I know the unit circle inside and out, but I don't know it like that. It takes me 5 to 7 seconds to come up with it, which is fine. I wouldn't necessarily have to write it, but I want you to see what I'm seeing in my brain. When I see pi over 6, I think of this. That's all I think about. If I write it, that's all I write. I don't need to put the denominator of 2 and a comma and a 1 over 2. Remember, the denominators of 6, you have two choices. It's either this or it's this. It's the same two fractions, just flipped. So if I remember that the first angle on the unit circle starts with the square root of 3, I got the rest of it. I don't need to write a comma and a 1/2 to know that the y value is 1/2. When I think of a denominator of 3, that's what I think of. That's it. If I see that 1 in my brain, I know that cosine is 1/2, right? I can fill in the 2 easily. And sine is square root of 3 over 2. You get those mixed up a lot. Pi over 2, not messing around with a quadrantal. Answer is 1. Okay? Now, what are these negative angles? Let's remember this. Here's the unit circle. We just covered sine in quadrant 1. Negative angles wrap clockwise. So we're actually in quadrant 4, but not using 11 pi over 6, 7 pi over 4, and 5 pi over 3, because those angles are reached by going all the way around and terminating here. We're taking a shortcut, right? We're going backwards into quadrant 4, which means these angles are negative. Not negative 11 pi over 6. It's the same distance. Like pi over 6, this is the same distance, pi over 6. This distance is pi over 6. But since it went this way, it just becomes negative pi over 6. So negative, 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 pi over 6, pi over 4, pi over 3. And negative pi over 2 at the bottom. Okay? So, guys, what you're going to see, I get excited. Quadrant 1, everything's positive. In quadrant 4, sine is negative. Don't forget what you already know. All students take calculus. Sine is negative there. So if I know what positive pi over 6 is, and we just talked about it, I know it's just negative if it's in quadrant 4. I know all my denominators of 4 are square root of 2 over 2, but I'm in quadrant 4, so I'm negative. And so on. Okay? These are the only values we use when talking about inverse sine. Look, it's from negative pi over 2 to pi over 2, and for that reason, it's for the reason that I just explained over there. So I want you to picture every time we do inverse sine is this half of the unit circle. Positive, negative. Wrapping this way, wrapping this way. Okay? So what was all of that for? Finally there. Whenever you're asked for an inverse sine, inverse cosine, inverse tan, or arc of any of those, the answer is an angle. The answer is an angle. And we're going to do in radians, okay, always. So what they're saying is where on this part of the unit circle, look, this part of the unit circle, where is sine 1? Now, I don't want you using this chart. I don't want you using your unit circle. It's going to be tempting, but remember, you need to know these on a test without having that in front of you. You need to know it in math life, okay? So if I don't have one of those square root of 2 over 2s or 1/2 or square root of 3 over 2, if it's a 1 or a 0 with sine, I know it's one of my quadrantals. So I take extra care there because I know I mess up on those a lot. And I go through kind of some of them. Is it at 0? 0 is 1, 0. So it's not at 0, right? Where is it going to be? What's another quadrantal in here? Well, I know it's not going to be down here because that's negative. This is the process I'm going through. Takes a couple seconds. It's okay. Up here is pi over 2. That's 0, 1. Okay, we are at pi over 2. The answer is an angle. It's a theta, pi over 2. Okay? Sine is 1/2. Okay? Watch my eyes. I constantly go like this. If sine is 1/2, I'm picturing the x and y. 1/2 is on that side. That means square root of 3 is there. That's a denominator of 6. Right away I can do that. If it's negative, we'd be in quadrant 4, which just makes my numerator negative. Those are my only choices, by the way. That's it. I can't go anywhere else. That's it. Gotta be one of those. Okay? Square root of 2 over 2, don't need a lot of thought there. I know it's my denominator of 4. Is it quadrant 1 or quadrant 4? Quadrant 1. It's positive. Everybody's positive in quadrant 1. Square root of 3 over 2 doesn't exist. I don't know what that is. It's not one of my exact values. That's going to get thrown in at you. Okay? We'll practice sine more in a second. Let's go to cosine. Now I'm going to go a little quicker here. Here's cosine. Up, middle, down, middle, and it continues and continues and continues. It passes the vertical line test. It is a function. It fails the horizontal line test, so its inverse is not. We need to restrict the domain of this function, and we're not going to use that section because that would still, that section, if I had another hand, I'd put a line there. It fails the vertical line, horizontal line test. So we use from 0 to pi. And there's that section from 0 to pi that you see here. So just cut it out of there and plopped it right here. This is the only part of cosine that we use. And here is it split. So it's just the x and y axis split. So what I want you to take away from that is, for cosine, we don't use these two quadrants. We use what I call sunrise. Sunrise. Quadrant 1 and quadrant 2. There's no negative thetas there. It's a regular old quadrant 1 and quadrant 2. Everybody's positive here and cosine is negative there. And those are the only two quadrants we can choose from. So let's do this again. 1, 0, right? That's where I am at 0 pi. Cosine is the first value, so it's 1. First angle on the coordinate plane, that's square root of 3 over 2. Then that middle guy, square root of 2 over 2. up closer to the y-axis, that's 1/2. And then we get another quadrantal. Okay, that would be 0. I have to write it or stop and think of the ordered pair for any quadrantal. All right, now it's the same exact thing. Remember, guys, all of your denominators with 3 on the whole unit circle have the same denominator, have the same value. Sorry, cosine at both of these denominator 3's. It's going to be a 1/2. What's different, though, from pi over 3? It's negative. That's it. Denominators of 4, we know what those are. But in quadrant 2, we're negative. What did you say? Oh, okay. And then we have our square root of 3 over 2 over by the pi. That's negative. And then what is this one? Negative 1. Okay, so that's negative 1. Okay? Now, that was just reviewing it, but remember, I really want you to be practicing this. When we get to the homework, of course I'm going to do a few with you and I'll put the key up, but I'm going to encourage you not to cheat. Okay, so let's go through some of these. Cosine, okay, again, sine or cosine, when they give me 0s and 1s, I know it's a quadrantal, so I want to be careful. So I think about the 3 quadrantals in this, and I go, okay, cosine is my x, and if it's 0, it means I'm not going left to right, right? So it's this point. That's going to be up at the top. Because where is 0, negative 1? Down here. This is not part of sunrise. You can only use these 2 pieces. So he just, oh, wait, why? Oh, because of this whole, we're only using from 0 to pi to restrict the domain. So we can't use all from 0 to 2 pi. We only can go to pi because it needs to be a function. So that's the only part. So he made a good point, which I want to point out. There are duplicates of almost everything on the unit circle. Let me just give you an example. There's a positive square root of 3 over 2 there, and there's a positive square root of 3 over 2 over here. Cosine repeats itself the same exact value, in quadrant 1 and quadrant 4. But when we restricted the domain, we don't have any repeat x values. It's just this one, positive and a negative. All of these, all of what I have in green, there's 2 of all of them on the unit circle. That's why we had to restrict the domain. Can't have any repeat x values. So we restricted it. Sine is this part, cosine is this part, and you're going to learn in a second, tan is also this part, the same exact as sine, but we'll get to that in a second. So that's why we want to remember this. So in a way, Levi is right. Cosine is 0 at the top and at the bottom. But when we're talking about inverse cosine, we are restricting to just sunrise. So it has to be at the top, pi over 2. Kind of makes sense, Levi? Okay. Cosine is 2. That's not one of our values. Don't try to trick me. Square root of 2 over 2, the minute I see that, I know that's my denominator of 4. It's positive. That's quadrant 1. Cosine is positive in quadrant 1 and negative in quadrant 2. Okay? Cosine is negative 1/2. So that's where it comes first. Cosine is first. That's a denominator of 3. But negative means I'm in quadrant 2. Remember your quadrant 2 tricks. Your numerator is 1 less than your denominator. So subtract 1 from 3, you get 2. Okay? So does not exist. Dead. It's undefined. Okay. Or not possible, you'll see. Right. Last one is tangent. Again, here's a squiggle. Squiggle, squiggle, squiggle. It's a function. It doesn't pass the horizontal line test, so we have to restrict the domain of this guy so that when we flip everything, we are a function. So we picked, surprise, surprise, right in the middle, that guy. Here he is, from negative pi over 2 to pi over 2. Same as sine. We use the same part of the unit circle. And there he is flipped. So let's remember our tan. Tan, I think, is easier than any of them. Tan is my favorite. I'm really fast with tan. So let's remember. Okay, so notice we're from negative pi over 2 to pi over 2. So inverse tan or arctan is, again, the same part of the unit circle, wrapping that way, wrapping that way, though. Positive here, negative there. Let's start at 0. Quadrantal. This is my ordered pair. Remember, tan is sine over cosine. Y over x. Okay? So 0 over 1. 0 on top is fine. All of my denominators of 6 are going to be what? Square root of 3 over 3, Danielle. Good. Adds up to 6. Right? Quick, everybody. Denominators of 4. 1. All of my denominators of 4 are 1 or negative 1. We're in quadrant 1, so it's positive. We can't get this wrong either. Denominator of 3's, square root of 3. Don't forget that. That's easy to remember. Not these. Not for me. I need the ordered pair. How long does it take you to figure out what that ordered pair is? Seconds. Right. And 1 over 0 is undefined. And remember, that's because we have that asymptote at pi over 2 and negative pi over 2. What's going to happen when we go backwards into quadrant 4? Same answers, but negative. Yeah. So denominator of 6, practice again. Square root of 3 over 3. We're in quadrant 4. Tan is negative in quadrant 4. All of my denominators of 4 are 1. We're in quadrant 4. Tan is negative in quadrant 4. All of my denominators of 3. Square root of 3. We're in quadrant 4. Negative. Tangent is negative in quadrant 4. Yeah. Again, though, I'm not in a chart when I'm doing this. I just get a question that's tan of negative pi over 2. I'm not looking at it like, oh, it's negative. You know what I mean? I'm showing what process I go through. Negative pi over 2, that's at the bottom, so 0, negative 1, negative 1 over 0. Nope, can't have it. Okay? So let's go through them. Tan of 1. That's denominator of 4. We're in quadrant, it's positive, so we're quadrant 1. Square root of 3, that's going to be a denominator of 3. But it's negative. So it's going to be what? Negative pi. So remember, we're wrapping this way. Same thing that happened with sine. These are your only options. This is it. Remember, we're not going the whole way around. We're going backwards. 0. Shoot. It's one of those quadrantals. And I have 3 of them. But, oh yeah, I remember at the top and the bottom I'm undefined. It's probably, and I'm double checking. Okay, at the right one, up or down 0, 0 over 1, 0 on top is fine. My answer is 0. Or 0 pi. Those mean the same thing. 0 or 0 pi. Square root of 3 over 3, denominator of 6. Immediately I know that. It's positive. That's pi over 6. Okay? Last thing is just, do you know how to round? This is basically, can you round to 3 decimal places? Most of you can say yes. We still are making mistakes on rounding, so this is good practice because it's really all that. So, guys, we just got quizzed on and asked questions on these angles that we know a whole bunch about, right? But there are angles in between. Like, there's angles all in here, and here, and here, and here. These are not the only ones. These are just the standard ones that we know a whole bunch about. So what if we get a number that is in between angles? Well, we can use our calculator. So inverse sine, we want to know what the theta is. We're going to get a decimal answer. That's okay. We just round. So inverse sine, sine, cosine, and tangent. I'm sure you can see them right in the middle. And then right above each of them in blue is your inverse sine, cosine, and tangent. So you just have to hit your second button. So for inverse sine, you're hitting second sine, 1 divided by 4. And I know you can't see my screen. But put it in your calculator, guys, and make sure you get 0.253. Now, always clear your RAM. Clearing your RAM, by the way, always puts you in radian mode. That's what your calculator defaults to. So it's another great reason for any time you pick up the calculator to clear the RAM in case somebody messed with you and put it in degrees. Because if you have your calculator in degrees by accident, you're going to get another yucky decimal. It's not like it's going to be a number you recognize. You're going to get a decimal that you round to, you're not going to know it's wrong. So clearing your RAM is always a good idea. All right, so let me give you if you want to just test yourself real quick, make sure you are putting these in your calculator correctly. Make sure you are rounding correctly. This one, you'll get an error. message. So you would write not possible, does not exist, whatever. Okay? All right. Listen, you're going to get your homework done with tons of time, okay? So it's only 9:35, and we're in here till 10 till 1. Okay, you have tons of time. So let's really, really try to do this the smartest way. You're stuck here with me anyway. Use the time to do the homework and actually try and not copy. Because you guys know, I'm going to put the key up in a minute. Oops, 1 through 20. I'm going to put the key up. The key's going to be on Canvas. You can absolutely copy. There's no work to show on any of these problems. So you can copy. But how is that going to help you? Take the extra few seconds per problem and really try. And then look at my key. So let me get you started again. Because now we don't have that chart in front of us. And now they're all mixed together. Okay? So first thing I want you to remember, if you look at the entire paper, all of the trig functions, sine, cosine, tangent, have that -1. Recognize that they're giving you exact values, and your answer is going to be a theta, okay, a pi over something. All right, so first one, sine at -1. That has got to be a quadrantal. Now, inverse sine, if you want to draw it for yourself, this is the same. Inverse sine and inverse tan. Use this part of the unit circle. This is something you have to know. And cosine uses what I call sunrise, which is these two, positive, negative. So we have to be in that area. Where are we going to have a negative number? It's going to be in quadrant 4, so it's probably down at the bottom. So that would be 0, -1. Yep, sine is that number. Where? Don't mean to write -1. What angle is that down at the bottom? Not pi over 2. Not 3 pi over 2 either. Negative pi over 2. Remember, we're going backwards. That's really important, okay? Let me just say one thing, because this is really important, guys. If I'm talking about, let's just talk about pi over 6. From 0 to pi over 6, that's a distance, okay? You could measure that. It's exactly the same distance here. So this is, if I travel, look. If I travel from here to here, that's not 11 pi over 6. That's still a distance of pi over 6. But since we're going backward, we say negative. What is 11 pi over 6? That's starting here and going all the way around. We didn't. We took a shortcut and went backwards. Okay? So understand that. Inverse cosine is 0. Okay, is it this one? No. It's where this is going to be that, and who knows what's there. That's going to be up at the top, pi over 2. Right? You have to stay within your boundaries for inverse cosine and figure it out. Draw a picture, whatever. Sometimes it helps to have this written on your paper so you can just see your zeros and ones really quickly. And even down here, 0, negative. Put your quadrantals on your paper. How long does that take? Not long at all. Where is tan 0? Now tan is different, right? These are all sines and cosines. But it's got to be one of our quadrantals with y on top. Well, you can get 0 here or here. Is our answer going to be 0 or pi? How do we know which one we use for this? Because of this. Remember, you can't use any angles over here for inverse tan. So it has to be at 0. Square root of 2 over 2, denominator of 4 for sine. Immediately. Positive, we're in quadrant 1. Some of them are easier. It's the quadrantals that get us. Get me anyway. I'll just do one more. I see the square root of 3 with a tan. Immediately my denominator is what? 3. Immediately. Then I see that it's negative, and I say, oh, okay, I have quadrant 1 or 4 as my choices. I'm going backwards. That's negative pi over 3. Actually, I'm going to do one more. Inverse cosine. Again, I can only pick from here or here. I don't really care about that yet, to be quite honest. Where is negative 1/2 first? What is that denominator? It's not the 6's, it's the 3's. Right? The first angle you come to on the unit circle has 6 in the denominator, and that's where the square root of 3 is. And then it's negative, so that means I'm in quadrant 2. Remember your numerator tricks. So in quadrant 2, all of my numerators are 1 less than my denominators. Okay, I'm going to put the key up. Try to find it in your brain, then look up and check your answer. I know it's tempting to just write them all down if you're tired and don't really want to do this, but use this opportunity to train your brain. Get it back in unit circle mode. You need it. Tuesday, Wednesday, Thursday, Friday next week, you need it.
Friday.